Section 1.2, Fractions. We'll start with some basic concepts. So, this is an example of a fraction, 7/9. We call the number above the fraction bar the numerator, and the number below is called the denominator. And again, the bar is called the fraction bar. So, identify the numerator and denominator of the fraction 3/10. Well, the numerator is 3, and the denominator is 10. All right. An important concept with fractions is this idea of what is called lowest terms. A fraction is said to be in lowest terms when its numerator and denominator contain no common factors. For example, we would say that the fraction 12/27 is not in lowest terms. Why not? Well, if we think of the factorizations, specifically the prime factorizations of the numbers, 12 can be written as 2 times 2 times 3, and 27 can be written as 3 times 3 times 3. So there is a factor in common. And so what we would say is 12/27 is not in lowest terms. And in fact, it can be reduced to lowest terms. But since there's the common factor of 3, it is not in lowest terms. The basic principle of fractions says that if there is a common factor between a numerator and denominator, we can remove the common factor. And in the other direction, it says if we have a fraction, we are allowed to multiply both numerator and denominator by the same number and get an equivalent fraction. Using the information shown in the previous slide, 12/27 is 2 times 2 times 3 over 3 times 3 times 3. We are allowed to remove the common factor of 3 and write it more simply as 2 times 2 over 3 times 3, which is 4/9. You may have learned in the past that you could do this. 12/27 divided by 3 divided by 3 is 4/9. And these two ideas are exactly the same. The idea of factoring and removing common factors will be more useful later on in the course. So now would be a good time to practice a little bit and try to simplify each of these fractions. So it would be a good time to pause and try these on your own. All right, 5/20. Now 5 cannot be factored any further, but we can always write a number as 1 times itself. 1 times 5 is 5. 20 can be written as 2 times 2 times 5. Removing the common factor of 5, we can write 1/4. And so 5/20 is the same as 1/4, where again I multiplied back out the 2 times 2. 60/105. Well, 60 can be written as 2 times 2 times 3 times 5. 105 can be written as 3 times 5 times 7. Removing common factors. Well, let's see. We have a factor of 3 in common and a factor of 5 in common. And so 60 over 105 is the same as 4 over 7. 28 over 70. 28 is 2 times 2 times 7. 70 is 2 times 5 times 7. Removing the common factors of 2 and 7, we are left with 2/5. All right, so how to multiply fractions? The rule for multiplication says that a over b times c over d is equal to a times c over b times d. So this asks us to simplify 7/9 times 3/14. The rule says that this is the same as 7 times 3 over 9 times 14. Now we can multiply these out. 7 times 3 is 21, and 9 times 14 is 126. But then we may need to reduce the fractions like in the previous exercise. So instead what I'm going to do is leave these in a factored form. 7 times 3 is simply 7 times 3. Those cannot be factored further. 9 can be written as 3 times 3. 14 can be written as 2 times 7. And now I see some common factors. I can remove the factor of 7. I can remove the factor of 3. Well, now wait a second. What remains in the numerator? Well, I could have always put in a 1 times, right? Because 1 times anything doesn't change anything, right? 1 times 7 is still 7. And so this reduces to 1 over 6. 2 times 3/8, I'm going to think of that 2 as 2 over 1, right? Because 2 divided by 1 is still 2. So now I have 2 times 3 over 1 times 8. And again, thinking factors, 2 times 3 I can't do much with, but the 8 I can write that as 2 times 2 times 2. I can remove the common factor of 2, and I'm left with 3/4. Before we go to division, we have to discuss the concept of a reciprocal. Two numbers are reciprocals if their product is 1. So for example, 2/7 and 7/2 are reciprocals because 2/7 times 7/2 would be 2 times 7 over 7 times 2. Removing common factors, and remembering that I can always have a 1 in the numerator or denominator, that leaves 1 over 1, which is 1. 2/7 and 7/2 are reciprocals because their product is 1. The easy way to find the reciprocal of the fraction is to flip it over. So the reciprocal of 3/8 would be 8/3. The reciprocal of 1/7 would be 7 over 1, which is more simply 7. Why don't you try the other two on your own? The reciprocal of 5/2 would be 2/5. And the reciprocal of 13, well, I can think of that 13 as a 13 over 1, so its reciprocal would be 1/13. We introduce the reciprocal because we need that for division of fractions. Division is equivalent to multiplication by the reciprocal. So if we have a over b divided by c over d, that's equivalent to writing a over b, the first fraction, multiplied by the reciprocal of the second fraction, d over c. So for example, 3/4 divided by 1/2 could be written as 3/4 times the reciprocal of 1/2 is 2 over 1, or more simply 2. But let's just write it as 2 over 1 for now. Now, using multiplication, we have 3 times 2 over 4 times 1. Thinking of that 4 as a 2 times 2, we can remove a common factor of 2. And simplifying, we have 3 over 2 times 1 is 2, so 3 over 2. Why don't you try these next two on your own? It'd be a good time to pause. All right, 8/15 divided by 2/25 is the same as 8/15 multiplied by 25 over 2. So that's 8 times 25 over 15 times 2. 8 is 2 times 2 times 2. 25 is 5 times 5. 15 is 3 times 5. And then we still have a 2. Removing common factors. And let's multiply that back out. 2 times 2 is 4. 4 times the remaining 5 is 20. And we have 3 remaining in the denominator. So we have 20 over 3. 32 over 27 divided by 16. Remember that 16 can be thought of as a 16 over 1. So we can think of this as 32 over 27 times 1 over 16. So that's 32 times 1 over 27 times 16. 32, let's see, 32 is 2 times 2 times 2 times 2 times the remaining 1. 27 is 3 times 3 times 3. And 16 is 2 times 2 times 2 times 2. Removing all common factors. Let's see, there's 4 2's common. And that's all I can remove. So I will have 2 over 27. All right, addition and subtraction of fractions. To add or subtract fractions, all you really need is a common denominator. And as long as you do have the common denominator, you simply add the numerators and leave the denominator alone. Or subtract the numerators and leave the denominator alone. But, and again, it's in red because it's very important, we must have a common denominator. So, for example, if we had 18 over 29 plus 7 over 29, that's the same as 18 plus 7 all over 29, which could simplify to 25 over 29. Now, 25 is 5 times 5, and 29 cannot be, 29 is prime, so there are no common factors, and this is simplified. 5 over 33 minus 2 over 33 would be 5 minus 2 all over 33, which is 3 over 33. Now I can do something with this, because 3 is, well, it's prime. 33 is 3 times 11, and I can think of 3 as a 1 times 3, and removing the common factor of 3, I'm left with 1/11. Why don't you try this third one on your own? All right, so this would give us 91 plus 17 over 104, which is 108 over 104. Now, I won't go all the way down to prime factorizations, but what I'll notice is I can write 108 as 2 times, actually I want to use 4 here, sorry. 108 is 4 times 27, and 104 is 4 times 26. And removing the common factor of 4, I'm left with 27 over 26. Of course, you would get the same thing if you went down to prime factorizations and removed two common factors of 2. Now, if you don't have a common denominator, so if you want to add or subtract fractions with different denominators, you have to first find what we call the least common multiple of the denominators, which we will abbreviate the LCD. You have to build up the fractions so that they have a common denominator, and then you can add or subtract as in the earlier examples. Now, how to find an LCD? So let's find the least common denominator for the following fractions, 1/9 and 5/12. There's a couple of different ways to do this. One way is to list multiples of the denominators. So 9 times 1 is 9, 9 times 2 is 18, 9 times 3 is 27, 9 times 4 is 36, 9 times 5 is 45, and go for a while. 12, 24, 36. The LCD would then be 36. It's the first number that shows up in both of those lists of multiples. An alternate method says find the prime factorization of each number. 9 is 3 times 3. 12 is 2 times 2 times 3. All right, so now what we do is we say, well, we see 2's. What is the largest number of 2's that shows up in one factorization? Well, I see 2 2's here. And we have 3's. What is the largest number of 3's that shows up in a single factorization? 2 3's. So then the LCD would be 2 times 2 times 3 times 3, which is 36, the same thing we got in the previous exercise. So now that we know how to find a common denominator, let's show how to continue with addition or subtraction in that situation when we do not have a common denominator. So if we have 4/5 subtract 1/4, we cannot subtract these fractions right now. Instead, what we would need to do is find a common denominator. You should be able to find that the LCD would be 20. So we need to rewrite these as something over 20 minus something over 20. We ask ourselves 5 times what number gives 20? 5 times 4 is 20, and we build up that numerator with the same value. 4 times 4 is 16. 4 times 5 is 20, and 1 times 5 is 5. So now continuing with the subtraction, we have 16 minus 5, 11 over 20. We check to see if this can be reduced, and it cannot, so we are done with this exercise. 14 and 35. This one's a little bit tougher. Try this one on your own before I do it. All right, so I'm going to use the factorization process here to find the LCD. 14 is 2 times 7, and 35 is 5 times 7. So, using the idea that we pick all of the factors that show up the maximum number of times they show in a single factorization, the LCD would be 2, since there's a single 2, times 5, there's a single 5, times 7. Now you say, well, wait a second, the 7 shows up in both of them. Yes, it does. However, again, the idea is what's the maximum number of times it shows up in a single factorization? It shows up once. 2 times 5 times 70, 2 times 5 times 7 is 70. So I need to rewrite these fractions as something over 70 minus something over 70. So then we say, okay, well, 14 times what is 70? Well, what's missing in the factorization of 14? We had 2 times 7, and the LCD is 2 times 5 times 7. The missing factor is the 5. 14 times 5 is 70, and 11 times 5 is 55. 35 times 2 is 70, and 2 times 2 is 4. So this gives us 51 over 70. And I don't believe that there will be any common factors between the numerator and denominator here. So we're done with that exercise. So here's a couple more that you should try on your own. All right, the LCD for this one, well, let's see. 8 and 15. 8 is 2 times 2 times 2, and 15 is 3 times 5. So nothing really in common here. We just pick everything. So the LCD would be 2 times 2 times 2 times 3 times 5, which is 120. So over 120 plus over 120. 8 times 15 is 120. 7 times 15 is 105. 15 times 8 is 120, and 4 times 8 is 32. And so this gives us 137 over 120. We might say, well, can we break this down any further? Well, 137 is not divisible by 2, because it's not even. It's not divisible by 5, because it doesn't end in a 5 or a 0. Is it divisible by 3? One trick for divisibility by 3 is adding the digits. 1 plus 3 is 4. 4 plus 7 is 11. Is 11 divisible by 3? It isn't, and so the original number is not divisible by 3. There can be no common factors. All right, the LCD for 20 and 30 is 60. So over 60 over 60. 20 times 3 is 60. 9 times 3 is 27. 30 times 2 is 60. 7 times 2 is 14. And so then this gives us 13 over 60, and 13 is prime, and 60 is not divisible by 13, so that one's done. Now, if we had multiple fractions, so now if we have 3 fractions, the idea is the same. We would need to find an LCD for all 3 of them. So I'll use prime factorizations again. 40 is 2 times 2 times 2 times 5. 50 is 2 times 5 times 5. And 100 is 2 times 2 times 5 times 5. So then the LCD, well, let's see, what's the maximum number of 2's? We've got 3 2's. And the maximum number of 5's is 2 5's. So 2 times 2 times 2 times 5 times 5 is 200. The LCD is 200. So we have 100 minus something else over 200 minus something else over 200. All right, so 40 times 5 is 200. 9 times 5 is 45. 50 times 4 is 200. 3 times 4 is 12. And 100 times 2 is 200. And 1 times 2 is 2. So then this would give us 45 minus 12 minus 2 over 200. And in order from left to right, 45 minus 12 is 33. 33 minus 2 is 31. 31 over 200. And 31 is prime, and 200 is not divisible by 31, so that is simplified. Alright, so now a few applications. Find 3/7 of 9/16. When you see a fraction and then the word of, that's it's a multiplication idea. So find 3/7 of 9/16, we can translate that to 3/7 times 9/16. And since it's multiplication, that's 3 times 9 over 7 times 16. And I don't think anything's going to reduce here. 3 times 9 is 27. 7 times 16 is 112. So 27 over 112 is 3/7 of 9/16. A rope measures 15 1/2 feet and needs to be cut in 4 equal parts. Find the length of each part. Well, if we cut into equal parts, that implies division. It must be equal parts. So what we have here is 15 1/2 divided by 4. Okay, now hopefully you remember something from pre-algebra or somewhere in the past. To change this to a fraction, 15 1/2, to change it to a fraction, we would say 2 times 15 plus 1, so denominator times whole number plus numerator, and write that over the denominator again. So that's the same as 31 over 2 divided by 4, which is 31 over 2 times 1/4. Remember, division is multiplication by the reciprocal. Multiplying fractions, we have 31 times 1 over 2 times 4, which is 31 over 8, and units, 31 over 8 feet. And if you wanted to go back to a mixed number, which is not necessary unless it's asked for, we would divide 8 into 31. It goes in 3 times with a remainder of 7, so we would write 3 and 7/8 feet. Determine the perimeter and area of the rectangle below. And here we have a rectangle with a length of 11/12 feet and a width of 3/8 feet. All right, so remember, perimeter you basically just add up the sides. So the perimeter would be 3/8 plus 11/12. And remember, this side is a 3/8 and this side is an 11/12. So plus 3/8 plus 11/12. Let's regroup these. So we have 3/8 plus 3/8, and then we have 11/12 plus 11/12. So now we have 6/8 plus 22 over 12. And wait a second, we're going to need a common denominator here. 6/8 and 11/12, let's see, that would be LCD would be 24. Both 8 and 24, 12 going to 24. 6 times, let's see, 8 times 3 is 24. 6 times 3 is 18. 12 times 2 is 24. And 22 times 2 is 44. So that gives us 62 over 24. And we can reduce that. There's a common denominator. What do we have in common here between 62 and 24? At least 2. So this can be written as, let's see, 2 times 31 over 2 times 12, or 31 over 12, right? Removing the common factor of 2. So the perimeter is 31 over 12 some of those would also the area. Remember, the area of a rectangle is simply its length times its width. So we would have 11/12 times 3/8, or 11 times 3, over 12 times 8. Hey, 3 goes into 12. Let's write that 12 as a 3 times 4. And removing the common factor of 3, we can write this as 11/32. And the units on area are always square units. So the area is 11/32, and we would have square feet as the units on that.